Hey calculus kids, this is Dr. Callahan with week 4 Monday. How are you guys doing? Let's go ahead and pause the video and answer the following questions. Okay, so let's go ahead and create the assignment for today. It is week 4 Monday and it is for APCalcAB semester 2. Today our topic is going to be U substitution with definite integrals. So we're going to find the area underneath the curve of a line using U substitution. Now your instructions today is as follows. Make sure you guys watch the video, view the assignments so you're not marked absent. And also you have your 2 links for today in class, which is a YouTube channel in addition to the Calculus Google Doc. Keep in mind that if you need to pick up hard copies, they are available. And then on the bottom is a schedule of the things that you should be following when you are on the hybrid model, when you're at home. So for you guys for second period, if it is Monday, Tuesday, Thursday, Friday, make sure you're checking in with me about 8:46 till 9:41. And then on Wednesdays, which is early release, 8:40 till 9:29. So that's the allotted time for you guys to use for this. This is due on Monday at 3 p.m. And I'm going to go ahead and give you guys the 10 points for that, and we'll assign. Today is Monday. I have not updated your grades yet because I'm making the video over the weekend. So technically it's not Monday, but I will definitely have the grades uploaded onto Infinite Campus and also posted on MS Team by Monday of this week. So make sure you guys check that out. So tomorrow's video, I will be showing you guys the grades for that. I did have a student who emailed me and said that, sometimes MS Team is a little glitchy and they're not able to view the assignment. That's totally fine. You guys just need to make sure you send me an email. Just let me know so I don't mark you absent on the hybrid at home days. And then as always, here is the link for your channel for the YouTube video for the class itself. And this is what you guys should have. And you should have everything from week 1, Monday, semester 2, all the way. And this is not part of it, my little boys. Let's remove it from the playlist. So sorry about that. Why is it saved to all of this? What is going on? Hold on a second. Oh my goodness. Okay, so why is it still here? Hold on a second. Let's see. Remove. There we go. And you have it all the way from week 1, week 2, and also week 3 because you do have the videos there. Most of the videos are around about 20 minutes. Sometimes they can go up to 30 minutes depending on the content and how much there is that we need to cover. So I would just highly recommend that you guys are watching this on a regular basis. All right, so with that said, let's go ahead and go back to your class. Okay, so your guided notes today are fairly simple for the most part. You just have one specifically that you need, which is this one right here. We're going to go over the 2 different examples on um, definite integrals with U substitution. I'm actually going to go ahead and paste this one over to your assignment. So for those of you guys at home, and if you don't have the guided notes hard copies, you have at least an idea what to look for. So if you click on that right there, you'll be able to see the problems, and you can just show your work on a separate piece of paper. Okay, so with that said, let's go ahead and move on forward. This is a breakdown of what we're going to be talking about today. We're going to go over 2 different examples on U Sub, and then we'll have you guys do some whiteboard practice on advanced U Sub problems. Okay, so let's go ahead and jump right in then. All right. So these are the two questions that you guys have. I will highly suggest that you guys kind of take a look at the common derivatives and the common integrals. And I actually just realized that this here was not transferred over to the notes. That's okay. I'm gonna take it and move it over very quickly. Sorry, I just have to do this before I forget. So, and then also, I believe this is from week 1. And I want to make sure I save this onto the guided notes for this class as well. And I just opened the wrong one, but that's okay. Hold on just 1 second, guys. Let's see, week 4, Monday. Okay, so now that I have that, we are good to go. So I realized that you guys did not have the common derivatives on the bottom of your guided notes, but it will be for next year's students. But if you don't have it, that's okay. You have this actually in your packet sometimes in week 1 of the derivatives versus integrals, because we do use them interchangeably. So it's in your best interest to make sure that you understand how to go about memorizing them. So, okay, so let's go ahead and take a look at the first question here. For example 1, notice that it is a definite integral. You have the integral between 0 to 1. And you want to use this as a U substitution. So here are some of the steps. I'm going to say let U, and you want U to be always whatever is inside the parenthesis. So in this case, x squared plus 1. Then you know that your du is going to be 2x dx. So I should put du equals 2x dx. Then your dx is going to be a du over 2x. And if you solve for x, x equals u minus 1 square root. Okay, now I'm going to go ahead and rewrite the integral. So I'm going to rewrite it as from 0 to 1, x times u to the third dx. Replace the dx, 0 to the 1, x times u to the third times dx is going to be equal to du over 2x. And you should notice that your x cancels, your 1 over 2, I could just move it over to the left side. And then if I add the 1, which is going to be a 4, divide the u by a 4. So times 1 over 4, u to the 4th plus c. So that gives me 1 over 8. Replace the u. Which is going to be x squared plus 1 to the 4th plus c. Okay, and you want to evaluate this from 0 to 1. So let's go ahead and do that. Your upper bound is going to have a 1, so I have 1 over 8. 1 squared is just 1. 1 plus 1 is 2. 2 to the 4th power minus, make sure you plug in the lower bound. So we have 1 over 8. 0 plus 1 is 1. 1 to the 4th power. So here you're going to have 2 to the 4th power, which is 2 times 2 times 2 times 2, which is 16. 16 divided by 8 is a 2 minus 1/8. Well, I would need to have a common denominator here. So if I put that at 8, this will become a 16. Subtract it, 15 over 8 units squared is your answer. All right, let's go ahead and take a look at example 2. Here are your steps for U sub. With example 2, notice that you have a square root on the bottom over here. The integral is from 1 to 5. So let's go ahead and say let u be 2x minus 1. Then your du is going to be just 2 dx. dx is going to be du over 2. And you can go ahead and solve for x. Last one, for example 1, we didn't actually have to use it. But for this one, you might, I don't know. So let's go ahead and just solve it just in case. So u plus 1 divided by 2. All right, so now that I have that, let's go ahead and rewrite this. Integral from 1 to 5. And I have x over u to the 1/2 dx. Replace your dx. You're going to have a du over 2. Okay, so in this case, it's not helping me much because I still have the x. It's not getting rid of it. So I'm going to have to solve for x. And that's kind of problematic because I now have a fraction on top of a fraction. So I don't like having a fraction on top of a fraction. So maybe I can move this u up into a u to the negative 1/2. So I'm going to replace this x with u plus 1 over 2 times u to the negative 1/2 du over 2. Then I'm going to go ahead and distribute this. So I can take the 2 here, the 1 over 2 and the 1 over 2 out. So I have a 1 over 4. Distribute the u to the negative 1/2 into the parenthesis. And here I have u times u to the negative 1/2. Remember, this is a 2 over 2, so it's really u to the positive 1/2. And after you guys practice this for a while, you'll be able to do this just in your head rather than on the side. Plus u to the negative 1/2 du. So now that looks a lot better. Let's go ahead and integrate this then. So plus 1, which is 2 over 2, that's a 3 over 2. Divided by 3 over 2, make sure you flip that. So I have a 2/3 u to the 3 over 2, plus, make sure you add 2 over 2 to the next one, which is a 1/2, divided by the 1/2. Make sure you flip that, which is just going to be a 2 over 1, which is just 2, u to the positive 1/2. And you're going to evaluate this from 1 to 5. All right, so next step, let's go ahead and plug in the upper bound. So actually, before you plug in the upper bound, we will have to replace the u back to what it was before. And you know that the u was 2x minus 1, 2x minus 1. Now we can go ahead and plug in the upper bound. So we have 1 over 4, 2/3, 2 times 5 is a 10, 10 minus 1 is a 9, and I have 9 to the 3 over 2, plus 2. 2 times 5 is 10, 10 minus 1 is a 9, so 9 to the 1/2. This is your first part, minus your lower bound, okay? Your lower bound, unfortunately, you're going to have another bracket in there because you have to distribute that negative in there. Although if you don't have it, just remember you're going to distribute the negative into the two different terms. So I have the 1, so I have 2/3. 2 times 1 is 2, 2 minus 1 is just 1 to the 3 over 2. Well, 1 to the 3 over 2 power is still just 1, so let's just put 1 right there. Now, this one has a plus, but remember there's a negative, so you have to distribute the negative. Minus 2 times 1 is just 2, 2 minus 1 is 1, 1 to the 1/2 is just 1. Here we go. If you go ahead and grab your calculator, just put in 9 caret 3 divided by 2, and then hit enter, and it should give you a number for that. So ultimately, what you're going to have is you are going to have essentially like a 6 for this entire region here, minus 2 over 3, which is from here. And then this is going to become a 3. That's going to be an 18, which is going to result with a 16 over 3 unit square. And that is your answer. All right, so those are the 2 different examples that we're going over in class. Now let's go ahead and practice a little bit more on a separate piece of paper. These are not in your notes. So let's go ahead and get started. Let's start off with the first one here. Integral of 1 over theta squared, cosine 1 over theta. Pause the video and answer the following question. All right, so let's take a look at this. We're going to let u be whatever is inside the parenthesis. This is a 1 over theta. Another way of writing that is theta to the negative 1 power. So I'm going to say theta to the negative 1 power. Then du is, you're going to do the power rule, bring down the negative 1, theta to the negative 2 dx. Solve for dx, or actually not dx. I'm so used to saying dx, but really it's d theta because there's no x. Then d theta equals du divided by negative 1 theta to the negative 2 power. So let's bring that up. So d theta is equal to a negative theta to the positive 2 power du. Okay, so then once I have that, let's rewrite this. And I have the integral of 1 over theta squared cosine u times, in the replace a d theta, okay, with a, okay, my pen is acting up, negative theta squared du. And that's perfect because this theta square and this one cancels, but you do have a negative 1, and that's okay. I'm going to move it over to the left. Cosine u du. Everything's in terms of u, so I'm good. I know that the integral of cosine u is going to be a sine u, so I'm going to replace that with a sine u plus c. So then once I replace that back, it's going to be a negative sine. U was a 1 over theta plus c, and that is your answer. Okay, let's go on to the next one. Okay, so for this one, it's one of those situations where, do I let u be cosecant or do I let u be cotangent? I mean, you really don't know, so you kind of have to just pick one and try it out to see if it works or not. So I would just say pick one, and see if it works out or not. So let's go ahead and say let u be cotangent x. Your du, derivative cotangent, is negative cosecant squared x dx. And then, of course, your dx is equal to negative, or du, over negative cosecant squared x. Now, if I have this, let's go ahead and plug this back in here. I have the integral of cosecant squared x, and already I can tell like this is the right move because you see the cosecant squared x is in the denominator. I have one in the numerator. I know it's going to cancel over, and instead of over, you can say times 1 over cotangent cubed is going to be u to the third power dx. You're going to replace a dx with a negative du over cosecant squared x. I can cancel this part right here. I have a negative, which I'm going to move over to the left side. And here I can move that up. And I will have u to the negative thirds du. Everything is in terms of u, which is perfect. And so I'm going to add a 1, which is a negative 2, divided by the negative 2. And I get rid of my integral. So then that becomes a positive 1/2 u to the negative 2 power plus c. Now I want to go ahead and put the u back, which is going to be 1 over cotangent x squared plus c. So my answer is going to be, another way of writing 1 over cotangent, if you think about it, is going to be tangent, right? So 1 over 2 tangent squared x plus c. On the multiple choice, you just really don't know which one they'll have, whether it's going to be in this answer format or the latter. So you just have to make sure you know how to convert them back and forth with both. All right, let's go on to the next one. All right, so this one says find the equation of a function with a given derivative passing through the point. So we've done this before in the first semester with derivatives where they ask you for in point slope form, but this one you have to use a U sub. So pause the video and give that a try. All right, let's go and say let u be whatever inside the parenthesis. So 4x squared minus 10. Then I know that my du is going to be 8x dx, and my dx is du over 8x. Next, I'm going to go ahead and rewrite the derivative, which is going to be, because right here you have the derivative. If I do the integral of this, this will give me f of x, which is what I'm trying to find is the original equation, f of x at 0.210. So then I will have the integral of 2x times u squared dx. I'm going to go ahead and replace the dx with a du over 8x. And I am able to cancel the x, which is great, and then have a 2 over 8, which is a 1/4 u squared du. Now that everything is in terms of u, I'm going to add the 1, which gives me a 3, divided by 3. I have 1 over 12 u, which I'm going to replace back is 4x squared minus 10 cubed plus c. So our goal right now is we want to find what c is, because I can't actually proceed forward with the equation until I know what that missing c is. But because they give me a point right here, let's do that. Y is 10 equals 112. 2 squared is 4. 4 times 4 is 16. 16 minus a 10 is going to give me a 6. So then I have 6 times 6 times 6, which is going to give me a 216. Divide that by 12 is going to give me an 18. So I have 10 equals 18 plus c, which means c is equal to negative 8. And there you have it. So then my answer is going to be f of x is equal to 1 over 12, 4x squared minus 10 cubed plus c, which is minus 8. And that is your equation. Okay, let's go ahead and go to the next one. I'm gonna go ahead and have you guys try this one. With this one, you're gonna realize that you will not be able to cancel the x, so you will have to solve for x in addition to dx. So go ahead and pause the video and answer the question. All right, so here's your answers and steps, so take a look at that. All right, I'm gonna go over one more example, you guys, which is number 67, which I don't have that here for some reason. That's okay, I'm just gonna quickly add this one in there. I don't know why it's not there, but that's okay. I'm not quite sure why it's not showing up here. Could you just give me a second? That's weird. Let's do insert, new slide. I'll just paste it here. That's weird because on my page it has it, but then on your page it's not there. Okay, so this works just fine. All right, let's go ahead and go on to the last one. Okay. So let's take a look at this one. With this one, what you're going to do is, remember, you're going to start off with let u be equal to what's inside the square root. So u is going to be 2x minus 1. Du is 2dx. dx equals du over 2. I'm going to tell you right now that you're going to have to solve for x. So let's just do it right now. So if I solve for x, I will have a u plus 1 divided by a 2. Now let's rewrite this. So I have x squared minus 1 on top divided by, and here in the denominator, which I don't like having this in the denominator, so I'm just going to put times u, which is 2x minus 1 to the 1/2 times dx, replace the dx with du over 2. And immediately you can tell that, there's no way you can cancel the x's, so you're going to have to rewrite a few things. Okay, so then I am going to go ahead and replace this x with what I solved for x with, which is going to be kind of ugly, but that's okay. So I'm going to move the 1/2 over, and I'm going to have u plus 1 over 2 squared minus 1 times u to the 1/2 du. Unfortunately, there is nothing that you can do but FOIL this, and I know you're like, "Oh, I really don't want to," and believe me, I don't want to either, but you're gonna have to FOIL the top and then distribute the bottom. So if you have u plus 1 squared, that's the same thing as like that, right? And I'm just focusing this piece right here to right there. So then you have u squared plus 2u plus 1 over 4. Now you have this with a minus 1 right there. Another way of writing minus 1 isn't that just a 4 over 4? I mean, my goal here is to kind of like combine the two fractions together. So then I have a u squared plus 2u minus 3 over 4. And then if you take a look over here with this, I'm just going to put it back on the bottom. Oh, that should have been a negative, sorry. Just so we have it consistent, and then we have a du. And of course, you have a 1/2. Okay, at this point, I think you kind of know where I'm going. You can go ahead and move this 4 out. So you have 1/8. And what I'm going to do is I'm going to go ahead and break this fraction apart. So I have u squared over u to the 1/2 plus 2u over u to the 1/2 minus 3 over u to the 1/2 du. Now, if I move that 1/2 up, it's going to be a minus 1/2. So I have u squared times u to the minus 1/2. This is a 2, and that'll be a 4, which will give you u to the 3/2. So 1/8 u to the 3/2 plus 2. Here you have a u times u to the negative 1/2. A 2/2 minus that is going to give you a u to the positive 1/2 minus 3u to the negative 1/2 du. Okay, now that I have this written out separately, you can pretty much just find the integral of this in 3 different pieces, but remember the 1/8 is over the entire thing. So let's do that. So plus 1, which is going to give you a 5/2, divided by the 5/2, you got to flip it, which is a 2/5 u to the 5/2 plus flip the 3/2, 2/3 times the 2, which is going to give me a 4 on top. So let's change that to a 4. U to the 3/2 minus plus 2/2 is a 1/2. If I flip that 1/2, it'll be a 2. 2 times a 3 is a 6. U to the positive 1/2 plus C. Wow, that was a long one. Okay, so then at this point, the last piece that you want to do is you want to replace the u and then distribute the 1/8. So if you look at this right here, the 2 and the 1/8 gives me a 1/4. So that's a 1/20. Replacing the u, which is 2x minus 1 to the 5/2 plus 4 and 8 is going to be a 1/2. So that's a 1/6. 2x minus 1 to the 3/2. Then the 6/8 is going to give me a 2 or 3/4. So minus 3/4. U is 2x minus 1 to the 1/2 plus C. And this is my answer right here. All right, you guys, I hope that was enough practice for you. As always, stay safe and healthy. I'll see you guys next time. Take care.